Hi, last time we left off, we were finishing number 10 here on example C. This is the one that uses the different 45, 45, 90 or the 30, 60, 90. We're just verifying through the tangent first. So this one we're going to do tangent of 30 degrees. Knowing what we talked about in the last video, we're going to find out something special about tangent of 30 degrees as well. If we go over to the other side, because we're doing opposite, so we have 4 square root of 3 over x. Now with this, knowing that tangent of 30, just from me knowing tangent of 30 is a value, special value, and it is 0.5773502692. Now, that doesn't mean anything to you right now, but it will shortly. Let's go ahead and finish out this problem. You'll see what I mean. So again, we have x in the denominator, so we need to multiply by x on both sides. So that will move the x from the denominator on this side to the numerator on the other side. Those two cancel. So we have x times tangent of 30 degrees is equal to 4 square root of 3. To get x by itself, again, we're going to divide by tangent of 30 degrees. So dividing by tangent of 30 degrees, tangent of 30 degrees. Those two cancel. So x equals 4 square root of 3 over tangent of 30 degrees. So if I take, again, you have to use closed parentheses in your calculator. So 4 square root of 3. Again, on your calculator, you'll need to do closed parentheses. On my TI calculator, I can just arrow over. And then divided by tangent of 30. And then that gives me 12. Now, I knew it was going to come out to be a nice even number, and the reason I knew it was going to come out to be a nice even number, because of what tangent of 30 really is. Tangent of 30 degrees is the square root of 3. That's why the x value here is 12. In fact, if we think about it, if this is the short side on a 30, 60, 90 triangle, then 4 square root of 3 times 4 square root of 3 is going to give us this value. 4 square root of 3 times square root of 3, 4 times square root of 3 squared, 4 times 3, that makes that 12. So that's why x is 12. So we verified it using our 30, 60, 90 as well. 4 square root of 3 times square root of 3 is the same as 4 square root of 3 squared, which is 4 times 3, and that's why it's 12. On this other one over here, so this is a 30, 60, 90. Again, this is the reference angle. So we're going to do tangent of 60 degrees. I'm going to turn on another light here. That may help, may not. We'll find out. I'm trying to change the shadow. Hopefully this is better shadow now. So tangent of 60 degrees is equal to, let's see, we have opposite, so 25 square root of 3 over adjacent, so x, multiply by x on both sides. So I have x times tangent of 60 degrees is equal to 25 times square root of 3. As you can imagine, just like the other one, tangent of 60 degrees is a special relationship as well. It doesn't look like anything now, but it will shortly. So 1.7320500808 divide by tangent of 60 on both sides, tangent of 60 degrees. So we have x equals 25 square root of 3 divided by the tangent of 60 degrees. So plug that in my calculator. 25 times the square root of 3. Again, you would use closed parentheses, divided by tangent of 60 degrees. And that gives me 25. And why is it 25? Well, if you think about this in the 30, 60, 90 triangle, this one's 30. This one is 25 square root of 3 divided by square root of 3. That's how we get from the long leg to the short leg. And so these two cancel. That's why we're left with 25 for the x value. Now for page 3. So for this top one, we're going to be doing finding the area of these triangles. So first thing we need to do is we need to find the missing leg. So to find the missing leg, this is length. We're going to do tangent of 40 degrees equals opposite, so 11, over adjacent, in this case x, multiply by x on both sides. So you have x times tangent of 40 degrees, 40 degrees equals, sorry about that, is equal to 11. Divide by tangent of 40 degrees on both sides. And you get x equals 11 over tangent of 40 degrees. So plugging that in my calculator, 11 divided by tangent of 40 degrees gives me 13.109. So x is approximately 13.1, and then the length looks like it's meters. So that's to find the length of that leg. Now the next thing I'm going to do is find the area. And to find the area, we do our formula for area of a triangle, which is 1/2 length times height, or 1/2 length times width. If I look at this particular problem, my 1/2 is 1/2. And then looking at my length and my height, I have 13.1 meters and 13.1 and 11 meters. 13.1 meters and 11 meters. So whenever I do area, meters times meters is going to give me meters squared, or square meters, so I know it's going to be my unit. So now I can just take 1/2, which is the same as 0.5, times 13.1 times 11. Multiply that together and I get 72.05. And then at the very top it said round your answer to the nearest tenth. So this is 72.1 meters squared. So that's our area, 72.1 meters squared. Do the same for the next one. So number 14. So tangent of 32 degrees is equal to opposite over adjacent, multiplied by 24 on both sides. Oops. Skipped it up here. 24 times tangent. 24 times tangent of 32 degrees. These two cancel. Left with x. 24 times tangent of 32 degrees is equal to 14.996. Now, I wanted to focus on this problem. If I round up to the nearest tenth, it rounds it up again. So we end up with x being approximately equal to, in this case, about 15.0 feet. So make sure that you note that, hey, it rounded and it changed the next value too. So now when we do our area formula, area equals 1/2 times length times height. So I have 1/2 times 15 feet times 24 feet. So I'm going to do 1/2 times length times height, and I get 180. Let me go ahead and do 0.0. We rounded earlier. We're going to keep that feet squared. If you didn't have the 0.0, I would accept that. That would be fine too. 15. This is a reference angle, so I have tangent of 56 degrees is equal to opposite over adjacent, multiplied by 40 on both sides. So I have 40 times tangent of 56 degrees equals x. 40 times tangent of 56 degrees. So that gives me x is approximately equal to 59.3 inches. So area equals 1/2 times length times height. So I have 1/2 times 40 inches times 59.3 inches. So 0.5 times 40 times 59.3. So that gives me area is approximately equal to 1,186 square inches. So that's the area ones. The bottom ones talk about perimeter. So we still need to find the missing leg value. So to find the missing leg value, we still need to do tangent. So we're going to do tangent of 36 degrees is equal to opposite. So for this one, We're going to call it x, opposite over adjacent. So I have x over 49, multiplied by 49 to get x by itself on both sides. So I have 49 times tangent of 36 degrees equals x. 49 times tangent of 36 degrees. So that gives me x is approximately equal to 35.6. 35.6. And now, to find the perimeter, we need to know the length of this side, and the length of this side. We know that this is a right triangle, so we know that it's a 30, 60, 90 triangle. So that means we can use a squared plus b squared equals c squared. And remember, c is your hypotenuse. So to find the hypotenuse, we need to do a squared plus b squared equals c squared. Doesn't matter which one's a, I can pick either one of these two. So 35.6 squared plus 49 squared equals c squared. So if I have 35.6 squared, it gives me 1,267.36 plus 49 squared. So that's 2,401. That equals c squared. So if I add 1,267.36 plus 2,401, that gives me 3,668.36 equals c squared. Now I take the square root on both sides. So if I take the square root of 3,668.36, that gives me this value. So c is approximately equal to 60 point, looks like that's 60.6. So if I add all of these values up for the perimeter, remember the perimeter, you add up all the sides. So perimeter is going to be equal to the 35.6 inches plus 49 inches plus 60.6 inches. So if I add all those up, we rounded, so I need to use approximately equal to symbols here. So we've got, move it so you can see. So we've got, let's see, 35.6 plus 49 plus 60.6, and that gives me 145.2 inches. Perimeter is just units, in this case inches, so we leave it as inches. For problems number 17 and 18, those are your bonus questions for this week. So make sure when you finish it that you show all your steps and explain your work in the discussion. And good luck. Hope you have a wonderful week. If you have any questions on 17 and 18, don't worry, I'll be posting the answers to those as well. They will appear before the homework is due, so don't fret about that. Yeah, have a great day. See ya.